Yep. PowerPoint file is so large, it takes a minute or two. Paused it. There we go.
There you
I got the class, to the classroom kind of earlier than we usually do to see if the camera, I was going to have to use my camera. It was beautiful how Zoom came up. So instead of jinxing it by getting out of Zoom, I just paused the recording. Did you find it? I know. Yeah, it's the 21st. The way that microphone thing is covered, it looks like a mini Death Star.
Like a little sphere.
Well, it has a little indentation on one side. It's smaller than what would be on a Death Star, but kind of is reminiscent of it. Some Star Wars, Star Trek, science fiction. Star Trek, the original series, when it was first on TV. I was in elementary school. I was just really getting into it when they canceled it. Yeah, stupid heads prevailed. Yeah, I was finally going to start watching, what was that called? Firefly? And Fox had canceled it.
What was that one about?
Oh, so you're not a brown shirt, huh? People who are huge fans of it are called brown shirts.
Oh, okay.
Yeah.
I wouldn't classify myself as one, sir.
Well, I kind of sort of, I mean, My family bought the DVD set of the one and only season of it. And then there was a movie.
So it was first a show, then they made it a movie.
Well, they made the movie after the show got canceled just to tie up some loose ends that happened in the show. But people wanted to give the fans, the production company wanted to give the fans some kind of closure. So they did the
Serenity.
Yeah, Serenity. And I saw Serenity before I saw the TV show, so I was totally lost in the movie. It was a cool movie, and I had no idea what was going on. And what am I doing? I'm waiting for Adobe to load up. That's not fun. It's not it. Wait, I would have been wrong. Okay. All right, what I have put up here is the review for the final. For the next exam, which is a week from today. And there are 24 problems on this. And as you can see, it has all the solutions here. Please realize that you are allowed to use the, didn't I post that? It is not there. Let me, I thought I posted it in this class as well. I did not. Wow. Losing my mind. Okay. The formula chart. See, I'm gonna find that file. For the trig formulas and trig formulas. This one. Okay. So under files, I'm putting the reviews. I'm gonna put the what do you call it? Someday I'll remember what I'm doing while I'm doing it. In files. I have put this. And this is all the trig identities that you could possibly use on the exam. You're allowed to use this on the exam. I'm not requiring you to memorize these. Although some of them you probably already have in your head, like specifically the some of the Pythagorean formulas, especially the first one you probably have in your head already. And we've used some of these so much that some of them kind of sort of sit there, so you're somewhat familiar with them. And then power reducing. So they didn't give the title of these formulas, these three formulas here. And from what I remember, they didn't give a name of them. They just gave these formulas, and they're the power reducing. So it goes from sine squared to a single power. So that's what they do there. And then somewhere down along the line, they take the square root of them. So if you take the square root of sine, you get plus or minus, and plus or take the square root of those three, you get plus or minus the square root of these three formulas. See if it shows up again. Trying to remember what they call them. And I don't even think they gave them a name. They just had them. And so this is in files, okay? In that particular under file in files, go to files and then exams and reviews and exam 2.
She say it'll be a week from today?
Yeah.
So Thursday, next Thursday?
On Zoom or here?
On Zoom. If you want to come here and take it on Zoom here, that is fine. I've had students do that. In a couple of other classes, they do that. So I bounce back to the review. So the identities on the exam or the review start start here. It starts with number 11. By the way, the exam will have 14 questions on it. So I've already written it. And the questions basically follow these. There's a couple of exceptions, but they're just still the same types of problems. And on those couple that aren't necessarily covered here, just the format is a little different. That's all. But it's nothing new and it's nothing you haven't seen already. So I put this in the
Files?
files. I don't think I put this in the files. Or did I put that in the files? I'm not seeing where. So let's see if I put it in there. I'm going to put the thing in the exam 2 here, and it's just a trig formula. So let me see if I can find it and if it'll let me do that. Because I have it open, I don't think it'll let me do that. But it's a PDF file, and sometimes they let you do things with PDF files can't do with other ones. And there it is. So you have the trig formula sheet in there, and you have this sheet in there. And I'm going to put another thing in there. And it is called trig identities. So it's not the formulas, it is just 57 problems that 57 problems of establishing identities. And there are 57 of them here. I probably should have done it in 2 columns. I don't know why I didn't. And then the answer, which shows you steps to solve these. Okay. So that's usually a good idea to try it yourself and then look at what steps they did. The thing about trig identities, there's no true one way to do it. There's usually a quick way, and then there's other ways that aren't as quick. That's all. Yeah, like the number 2 here. To turn this into secant, I would look at what tangent is and sine. I would turn both of these into sine and cosine. So this would be sine over cosine, and this is 1 over sine. So sine over sine goes to 1, so that just leaves us 1 over cosine, which is secant. So that would be an easy one, or at least in my mind. Now, I think we did this one in class, where you would rewrite the square. You'd write it as the sine of negative theta being squared plus the cosine of negative theta being squared. Well, the sine of negative theta is the negative of sine of theta. I haven't squared it yet. And cosine of the negative is the cosine of the positive. So this is just cosine of theta being squared. And whenever you square a negative, it becomes positive. So this is just sine squared theta plus cosine, I'm writing a G, cosine squared theta, which in fact does equal 1. So we're done with that. So do y'all see any problems here that you would like me to explore? Either with the trig identities or with the review. With that a little bit out of the way. See, whoa. What the devil?
Could we start with the number 6 on the trig identities?
Number 6. Okay.
Sine.
I don't know what I did there.
You can have them side by side. Right? Yeah, well, we almost had it.
No, I don't. Just let's do this. Okay. So everything is in all the different trig functions over here, and over here all we have is cosine. So I'm gonna write I'm gonna write tangent and cotangent in terms of sine and cosine. So I'm gonna get, let's see if I can get one that's darker than this one is. So, and I'm gonna worry about this sine in a moment. So that becomes sine of x divided by the cosine of x times cosine of x minus the cosine
over
of
sine.
x over sine of x times cosine of x. And out here we have sine of x. And now you do your multiplies and simplifies. Here, this simplifies to just sine of x minus cosine squared of x divided by sine of x. And we're still multiplying out here by sine of x. And now we do the distributive property, multiply each thing in over here. So this is going to be sine of x times sine of x minus sine of x times cosine squared x over sine of x. So these two signs over here go to 1. And so this just becomes sine squared x minus cosine squared x. I need a trig identity. I think the trig identity I'm thinking of has sine minus sine squared, cosine squared minus sine squared. So where do I put my trig identity? This one. Okay. So cosine minus sine. But but they're in the wrong order here.
Yeah.
So these are in the wrong order. So if I divide out a negative sign, I mean a negative, then this is the negative of cosine squared x minus sine squared x, and that's right here. And I want it to look like, I forgot what I wanted it to look like. 2 cosine squared minus 1.
1 minus 2.
Okay, this is what it is there. Okay, so I want minus 1 minus 2 cosine squared x. This is my target, right? Well, what I have in here is the 2 cosine squared minus 1. So, but I still have a minus sign on the outside. So I'm gonna write it over here. So now I have a minus 2 cosine squared x minus 1. And now when I'm multiplying by the negative sign, I'm switching the direction of the subtraction. Because this one, the 2 cosine squared becomes negative and the 1 becomes positive. So I'm switching which one's being subtracted. So this is 1 minus 2 cosine squared x. And we're done. That one was a little tricky, but not too tricky. Oh, that looks weird. Get in a hurry, and I write it at an odd angle. And what I write just kind of goes spastic. Other than my horrible handwriting, does everyone understand what was going on here?
Yes.
Anyone have questions on what I did there? I need to pull this in so I can see people. Although nobody's on camera.
No, sir, I am not asleep.
What?
So I'm just trying to track, because you're kind of all over the place here.
Yeah, I know.
Get down here, we turn that into negative cosine squared x minus, and then that turns into,
Because I knew this was one of the this triggered something in my head.
right,
So I came over here and I looked for it,
yeah,
but it's in the wrong order. I'm subtracting the wrong way. So I factor out a negative sign. So now the subtraction goes the right way.
right. And then that's,
And so I just replaced this with this one here. Because this one equals, all four of these are the same.
okay, yeah,
So I can replace this with cosine 2 theta, I could replace this with 2 cosine squared theta minus 1, or with 1 minus 2 sine squared theta. Remember that with the double angle formula for cosine, you have 3 separate formulas. The textbook gave us 3 separate formulas, but they're all just equal to each other. We have the transitive property. Of equality happening here. Or just straight substitution. Now, either the review or the trig I didn't use. I'm doing more of the trig I didn't use.
let's see the other one. Oh,
Yeah.
15,
There's 57 of them. What? Which one?
number 15,
Number 15. Okay.
maybe. It's kind of crazy. I'm gonna convert.
Let's try this. So 1 minus cosine squared u. I wish they would use theta all the time, but they don't. 1 minus sine u equals a negative sine of. What does, I'm going to write this as a single fraction because I just have a single term over here. Here I have 2 terms.
Right.
So to write this with the same denominator as this one is just 1 minus sine over 1 minus sine. So you have 1 minus sine u over 1 minus, well, I'm just going to write it 1 minus sine u. I'm skipping a set of minus cosine squared x u, whatever. Yeah. 1 minus cosine squared. What is 1 minus cosine squared? What's 1 minus cosine squared?
Minus. Oh, that's our trig,
The Pythagorean,
the Pythagorean function.
one of the Pythagoreans.
Sine squared theta.
1 minus cosine squared, 1 minus cosine squared, right? If you have sine squared plus cosine squared and they equals 1, if I subtract 1, I get the other one. If I subtract sine from both sides, I get cosine squared. If I subtract cosine squared from both sides, I get sine squared equals 1 minus. So 1 minus cosine squared is sine squared. Right? Because of this right here. So this right here is sine squared u minus sine u over 1 minus sine u. Now, wouldn't it be nice if I could factor out 1 minus sine?
Yep.
Well, I can, except notice if I factor out sine, I get sine times
You get one.
sine minus 1.
Doesn't it just, yeah, doesn't it just equal 1 when you factor out the sign?
You're still gonna have something there. Because I can't do any factoring yet. Remember, this is a single number.
That's one term.
That's one term. That's a single number. So if I can't take the whole thing out, in other words, there isn't a 1 minus sine u in the numerator, I can't take it out.
So then we convert.
Well, if I do factor the sine out of both of those,
I was gonna say, don't you just get 1 over 1?
no, I get sine u minus 1 divided by 1 minus sine u. The subtraction's going in the wrong way.
Yeah.
So I need to factor out a negative sign from either the numerator or denominator, just one of them, not both of them.
Okay.
So I'm gonna have a negative, see, I'm gonna need a negative. So I'm gonna factor negative out of that one. And so it's gonna be a negative sine u times 1 minus sine u divided by 1 minus sine u. Okay. The whole trick here is I'm trying to get rid of things, and so to get them to be the same, numerator to denominator, I have to be able to know how to manipulate the expressions to get them to look like I need them to look. Well, to get this factor here to look like this factor down here, I need to factor out a -1. Because then the sine u becomes minus and the 1 becomes plus. And I have a negative sign out front. Now I can take away 1 because now these go to 1 and it just leaves me a negative sine of u. Which is what I wanted. Which is what I was looking for.
These are our trig identities.
Trig identities. A trig identity is stating that this side of the equation is the same thing as this side of the equation. They're identity because A equals A. this equals a number, and this equals the exact same number.
Right.
So that's why they're called identities. On the test, you will get a question that says, show that these equations are equal. Well, that's just setting them equal to each other and then establishing the identity.
Okay.
All right, realize on the test, what you've been seeing so far has been, okay. I see my mouse moving on my screen here, but it's because it's on there. Okay, so that kind of confuses me a little bit. So far, you've been seeing where the more complex side is usually on the left-hand side. Take a look at number 16. We could attack either side. I could attack the minus sign here and try to make it more complicated to look like this. And how I would do that is multiply numerator and denominator by 1 minus sine u. And then try doing finagling, I go backwards with it. So I would multiply by 1 minus sine u over 1 minus sine u. And then I do the distributive property. And at some point along the line, I bring that minus sign in. And so then I have sine squared u minus sine u. And then I know sine, because I need to have a cosine squared, so I'd rewrite the sine squared u to 1 minus cosine squared u. And then I'd rewrite this, so I'd have sine u, 1 minus sine u minus cosine u, and then write that as two separate fractions, where I have 1 minus sine u over 1 minus sine u minus cosine squared u over 1 minus sine u. And then the 1 minus sine u over 1 minus sine u becomes the 1. So I do the exact same thing, just in reverse, to make it more complicated. But it's usually easier to take the complicated side and make it less complicated. And a lot of times that's how they develop these problems. They start out with the less complicated side and see what they can do to make it more complicated. $11. I'd square both of these.
Oh, yeah. Difference is, no.
No,
No,
you're squaring a binomial.
yeah. Oh, so you just, you make it a polynomial?
Well, you make it
Trinomial.
quadratic. You get tangent squared plus 2 tangent b plus 1 plus tangent b squared minus 2 tangent plus 1. So the 2 tangent would, they would go to 0 because you have a plus and a minus. And so you're left with 2 tangent squared plus 2. And then you factor out the 2,
Yeah.
and so you have 2 times tangent squared plus 1. Tangent squared plus 1 is secant squared. And it was 2 times, so it becomes 2 times secant squared. That one was pretty straightforward, but it's doing the algebra. Okay. You're at a point in your mathematical career that the algebra never goes away. So that's one of the hardest things for pre-cal to start realizing. Even for college algebra, for them to realize is that the high school algebras, you keep using it.
From here on out, it doesn't look bad.
Algebra is the basic tool for all of mathematics. which includes manipulating fractions. And I swear, the more you understand fractions, the easier math is. Because how do I change this to a single term? Well, that's writing this as a fraction with the same denominator, so I could write it as a single denominator. And then I play with the numerator until I get to a point where I get a single term being divided by 1, basically. What's that? Huh? Well, that was a check mark. Okay. All right. Well, let me go down because there was one I did in another class that was quite interesting. I don't remember which one it was. No, I didn't know. Don't worry about number 30. You won't see one like that on the exam. Not that cool. Oh, they did number 33. 33. Because they throw in logarithms here. That's the second half of college algebra, logarithms. So we're using some of the properties of logarithms. The log of a product is the sum of the logs of the factors. And I'm using natural log here because the problem is in natural log. But this is log of any base, as long as everything is in the same base. And the equal sign means you go both ways. You go both ways. The natural log of a quotient is the natural log, is the difference of the natural log of the numerator and denominator. If you had me for college algebra, you would have heard me say this a lot. And logarithms are exponents. When you're dividing like exponents, like terms, or you're dividing like variables, you subtract the exponents. So here I'm dividing, I got a quotient, so that means I'm going to be subtracting the exponents. These two are exponents that you put on the base to get the argument. It's another phrase you would have heard me say a million times. So we're going to use one of these in this one. We're subtract, and I would start with this side to make it look like this side. Or I could start with this side to make it look like that. That might be easier.
Yeah.
Because then I'm going this direction. Because cotangent is cosine over sine. So we have the natural log of the absolute value of the cosine of u divided by the sine of u. And then we use this formula. Why do we have absolute value around cosine and sine and cotangent? Anybody recall about some of the properties of
keep it positive,
yeah,
no negatives.
no negatives. The domain of logarithms is x has to be greater than 0. And which it means it can't equal 0 either.
So it must be positive.
And if I remember correctly, cotangent doesn't exist at 0. But cotangent does give you zeros in 2 places, so you'd have to exclude that particular angle. And so this just becomes, this is just this. by using this property from the of logarithms. Now, number 34 uses two properties of logarithms. We have because we're adding, that means I can write this as a single logarithm of the product of the two arguments. So we have the natural log of the absolute value of 1 plus the sine of u times, so this is one argument, and we're going to multiply it by the other argument, 1 minus the sine of u, absolute value in there. So the absolute value symbols never disappear. Well, here I have a sum and a difference of the same two terms. So I'll get the difference of two squares. 1 squared is 1 minus sine squared. Or you can do the binomial multiplication and you'll get the same thing. But what's 1 minus sine squared?
Cosine squared.
Cosine squared. So this becomes the natural log of the absolute value of cosine squared u. Now there's another property of logarithms. When you take the log of a power, so something raised to a power, then this is the same as the power times the logarithm of the argument that you have raised to a power. Now, if you don't remember that rule, one way I like to explain it, if I have the natural log of x to the fourth, well, that's the same as doing the natural log of x plus the natural log of x plus the natural log of x plus the natural log of x. Because x to the fourth means I'm multiplying 4 of them together. So that means, so this rule, I erased it. The product rule states if you're taking the log of a product, that's going to equal the sum of the logs of the factors. Well, here's all the factors. Right? The x's are the factors. How many of these do I have? There's 4 of them, right? So this is 4 times the natural log of x. That's how come you can do that with the exponents. Well, here, this is the same as saying cosine u times cosine u, which is the natural log of cosine plus the natural log of cosine, which is just 2 times the cosine. I mean, the natural log. I wonder why it looked weird. The absolute value, I mean, the natural log of the absolute value of cosine, which is what we needed to get. So anyway, oh, here. So this is what we got. Now I could have just used the product rule a second time. To get this, or use this property to get this. Either way, you're going to get here. And technically, I could put this type of problem on the test, but you won't see that. But this is a good review to kind of
Logarithms.
spark those things in your head again. Because when you get into calculus, you're going to be using these properties. Okay.
What are you suggesting?
Why not?
I'll let someone else do it.
Some of these are scary.
Yeah. I think, go.
What?
Go back up a little bit. Oh, yeah, the 39.
39.
Since we have a negative and a plus, we have to make, how do we make them?
Oh, 39?
Yeah, do we have to have the same denominator, correct?
Yeah, so I'm gonna multiply and that's exactly what you would do on this one, is to get the denominators the same. So you can see what happens, because we have a single term over here, I wanna make this a single term.
So I'm gonna multiply 1 plus cosine to the 1 minus, and the 1 minus, I'm gonna multiply to the 1 plus cosine. And then on over here, I'm gonna 1 minus. We end up with the
Yeah,
same
sine
thing.
X over in both of them, right?
So that's how we end up with the same denominator.
But in the denominator, because these are what are also known as conjugate pairs, you get a difference of 2 squares. So,
When you multiply together.
right, so you're gonna end up multiplying them together and get 1 minus cosine squared x, which is just sine squared x. Because that's a very common Pythagorean identity that we use.
So when I multiply 1 plus cosine x times 1 minus cosine x, I get, 1 minus cosine squared x with plus 0.
Yeah, because the middle term goes to 0.
Yeah, the middle terms.
So
get
boom,
disintegrates, basically.
So now in the numerator, I'm gonna go ahead and multiply these out. And so I have
One.
sine x plus cosine sine x plus sine x minus,
1.
no, I'm
Wait,
multiplying,
which one are you doing?
I'm doing both of these.
Oh, you're putting them all together in one?
Yeah,
Okay.
so I need more space over here.
Yeah.
So 1 times sine is sine, 1 times cosine is cosine
Cosine
sine.
sine.
1 times sine, 1 times 1 is sine, 1 times minus
Negative.
cosine is minus cosine x sine x. And we already discussed that the denominator became sine squared x. And so here I have positive sine, whoops, not that one. I have positive cosine x sine x, forgot the
You
x.
subtract.
And then I have a minus cosine sine. Those go to 0.
2 sine x.
So you wind up with 2 sine x here, which is 2 divided by sine x, which is 2 times cosecant
X.
x. What were we trying to get?
2 cosecant x.
Okay. And I didn't even have the end result in mind when I got to it.
It's just following the processes to a T.
But I knew I had to get to one single term with no fraction. And I have a coefficient of 2, which happened, would have happened when I had sine and sine. being added. We're using what we know from algebra and from fractions to rewrite the expressions so we can start manipulating it even further to get to where we want to be. So I knew the reality of adding fractions to get the same denominator. And then I looked at the product of the denominator and looked to see, is there a trig identity I can use that and that? And yes, there was. So that, boom, that was easy. And then I just multiplied in, I did the distributive property. I'm multiplying this expression by sine, and I'm multiplying this expression by sine. So that gave me these two expressions that I'm adding. If it was a minus sign, I would have put a parentheses around these two with the minus sign on the outside. And that would have changed my signs in it. So instead of adding sine and sine, I would have subtracted the two. And I would have gotten 2 times cosine x sine x. Well, what is 2 cosine x sine x? 2 cosine x sine x. I think we're used to seeing it written as 2 sine x cosine x. Isn't that the double angle for sine? Let's see. Double angle? Where's the double angle?
It equals sine 2 theta.
So if this was minus instead of plus, this would have been sine of 2 theta or sine of 2x. So the signs play a very, very, very important role. So keeping your signs straight.
And by that you mean our positive and negative,
Right.
right? Okay.
Yeah. Okay. Yeah.
Because we got.
The plus or minus plays a very important role. Okay.
As well as keeping the sign, actual sign.
Right. This is so bizarre. Because I moved the mouse off of this screen and it comes back on this screen because it's, that is weird. Okay. So look, what I'm going to do is I'm going to look at the review. So on the review, yeah. Looking at before number 11 from 1 through 10, because that's been a little bit since we've seen those. What angle of sine gives you 1/2?
30.
Yeah.
30. 30 comes
Pi over 6.
power 6. Here you go.
Well, I would accept 30 as an answer, as long as you put the degree on it. And so what's cosine of 30? What's cosine of pi over 6?
2 times
Nope,
the square root of 2.
nope. need to know your unit circle.
I knew it, I knew it. Right?
And it always helps me to draw it. I draw it for a reason.
Square root of 3/2.
Yeah, because this point is the square root of 3/2, 1/2.
1/2.
And this is the sine and this is the cosine. This is the x, this is the y. If you square those and add them together, you get 1, which is the radius of the circle. So number 5 is, what was it? Let's see what they get. What number was that? That was number 5, right? Yeah. Square root of 3/2. So we're so those kinds of things. So what angle is the cosine that gives you the negative square root of 2/2?
The next one over.
Well, when you're talking,
pi/4.
no, when you're talking about these, you're restricting where because sine inverse and cosine inverse. For sine inverse, we're looking at from 0 to pi. For our domain, for inverse sine, for inverse cosine, it is a negative pi/2 to pi/2 for the domain. So what angle? Wait a second, I got those reversed, don't I?
Yeah, what do you need to do?
Yeah, this is the domain for sine, and this is the domain for cosine. So cosine to get a negative square root of 2, yeah, I'm talking about that angle. 3 pi/4. And sine of 3 pi/4, because
Is
sine,
negative square root of 2/2. Oh, no.
yeah,
Y is sine, right?
we're talking here.
Yeah, but y is sine, correct?
Y is sine.
Okay, so then, no,
Which angles are positive here? Which trig functions are positive up here in the second quadrant?
sine and.
And it's reciprocal. Cosecant.
Cosecant.
Because sine is the y values, and if it's above the x-axis, it's going to be positive. So this one is a positive square root of 2/2. This one gets tricky. Because you want square root of 3 in the numerator, that means that you're going to be dividing by the square root of 3/2. So which angle gives you
Cosine.
no, I'm talking about the angle that gives me square root of 3/3, which is 1/2 divided by the square root of 3/2.
pi/6.
Is it pi/6?
Oh, no, what's the
Tangent is what?
cosine over sine? No, sine over cosine.
Sine over cosine.
Okay, so then,
So if this is the sine, this is the cosine.
so then, yeah, pi/6.
Pi/6. So what's the cosine of pi/6? So knowing those. Yeah. Sorry. Every now and again, I tell you about my fake teeth and they're just doing something weird today. I have
Didn't you say you're gonna get new ones?
Yeah, these are my temporary fake teeth. And in December, I go in for another fitting. And
That's
then I
soon.
think in March, I'll get my permanent fake teeth. But there's a little bit of a gap between the denture and my gums. And something was going on there. It's feeling weird.
Isn't there like a pink jelly you put in between so it doesn't like get loose?
Oh, they're not loose. They're bolted in. They're bolted into my jaw.
Oh, I know
Yeah.
what you're talking about now. I remember
So
seeing a video
I'll
about that.
never be able to take them out. They're implants. Is basically what they are.
Yeah, I know what you're talking about now. They literally drill like holes in your gums, put like
Well,
like a
into the
tube.
jawbone.
They put like a little tube where it's what is it called? Threaded, like a threaded tube so that they can drill the teeth into your gums.
Well,
Right?
basically what they did was, not to get too gross, they yanked all the teeth out of my mouth. So I have all my teeth, they're just in a plastic bag at home.
Whoa.
Okay. So
Make a shark tooth necklace, except for it's a Thomas Reed
I have
tooth
a human
necklace.
teeth necklace. I think I'm a cannibal. Anyway, and then they fill in, well, then they go in and oh, I'm so glad I was out for all of this. They go in and they clean it all up and drill it all down, and so they can put in this packing material that's basically cement. And it's a quick drying stuff, and so they make sure that it adheres correctly and all like that. And then they drill in where they're going to put the anchors for the implants. And so there's 4 of them across the top and 4 of them across the bottom that these fit into perfectly. And so they put these in. These are temporary. And I had instructions for 6 months of what I could and could not eat. So it will allow it to heal and that the cement material would harden and the bone would end up replaced, because I've had an implant put in before, which I still have. It's in my bag. But the bone eventually grows in and replaces the packing material that they put in there. So it's a permanent part of my jaw and my mandibles, or whatever the hell they're called. And so the rest of it is just waiting for them to finish my new teeth, my new fake teeth. And when I go in, the dental technician has this little screwdriver, pulls out all 4 from the top. And it's kind of weird when she pulls it out. And so I don't have any teeth in my mouth. I have pictures of that, and of where I don't have any teeth in my mouth. I took a video of myself and sent it to my family, and my wife said, "Don't ever show that to anybody." I find it hysterical. Anyway, I understand why old men without teeth talk the way they talk. It's damn weird.
So you should ask for vampire teeth and a gap just big enough for you to whistle like the cool way, the Western way, in between your buck teeth.
And the whistling I do is because I have a fake palate up here, so I haven't learned how to talk without making it whistle. But the new, the one, the permanent ones, that palette that comes out won't be as severe, and so I won't have that whistling going on.
Mm,
Boy, when they put those, they're wax teeth, but they're not like candle wax. It's very hard wax. And boy, they felt great. I mean, I talked more normal.
yeah.
I didn't feel like I had mush mouth like I do now. Anyway, I'm sorry, I didn't mean to go and tell you my life story, but anyway. Oh, we did 1 through 5 already. Okay. The sine of what angle between, for sine is from negative pi over 2 to pi over 2, and it equals the endpoints. Because that covers all the positive and negative numbers that sine could equal from -1 to +1. So that means x has to be between -1. Actually, this is what theta is, and so x has to be between 1 and -1. So what value of x does the sine of, that's just sine of pi over 2. What's the sine of pi over 2?
90.
No, you're telling me that 90 is pi over 2.
Oh,
not
no,
what
no.
sine of pi over 2 is.
The sine is 0. No, 1, 1, 1, 1, 1, 1, 1, 1, 1.
Cosine is
I
0.
keep forgetting that sine doesn't go first. Cosine goes first.
Yeah.
Cosine is x, sine is y.
And how I actually learned it was, instead of talking about x and y and that cosine is the x, I learned it that it's cosine theta, comma, sine theta. That's the ordered pair around the unit circle.
Cosine.
Yep, right. And any point, it's r times that. So if r is 1, then that's why we don't typically talk about this when r is 1. But like if r is 3, then you're going to multiply cosine by 3 and you're going to multiply sine by 3 to get the y value. So number 2 should be just as easy, I think. So what is the sine of pi over 6?
One and a half.
Yes. That's yes. We do that in my house instead of talking to each other, saying yes or no. We do that. We picked up some sign language, not a whole lot. Okay, so to number 3, you have to do some algebra first. So you have to divide by -4. So the sine, what tangent, or what is the tangent of -pi over 4?
Pi over 2, pi over 2. Or not pi over 2, square root of 2 over square root of 2.
No. Oh, yeah. No.
Wait, what did you say? Did you say?
Tangent inverse of x is going to equal a -pi over 4. And for inverse tangent, for it to equal 1, it's going to be from -pi over 2 theta to pi over 2, but it won't equal the endpoints there in that range. So theta, this theta is is in this range. So now we're looking at the tangent of pi over 4. Negative pi over 4, I'm sorry. And again, looking at the unit circle, where is tangent positive? Tangent is positive in the first quadrant because all of them are positive in the first quadrant. But tangent is also, nope. Remember, tangent is dealing with sine and cosine. So when cosine and cosine have opposite signs, tangent is going to be negative. When they have the same sign, tangent is going to be positive. Because you're dividing positive by positive or negative by negative. And so you're dealing with the first and third quadrant is where tangent is positive. But negative pi over 4 is down here. So that means it's going to be negative. All right, at the 45-degree angles, tangent is either +1 or -1 because it's sine over cosine. And sine over cosine,
Square root of 2 over square root.
square root of 2 over 2 over the square root of 2 over 2, and then you have to throw in the appropriate sign. So you have square root of 2 over the square root of 2, but the sign is going to be negative, so it's a negative square root of 2 over the square root of 2, which is a -1. So this one is done very similar to this one, but you're dividing by 6. So you get the cosine inverse of x equals pi over 6. Pi over 6 is in the range of cosine inverse. So what is x?
2 over square root of 3 is the inverse of the cosine of pi over 6.
Is what?
2 over the square root of 3 is the inverse of cosine at pi over 6.
No. Inverse functions take you backwards. You're thinking reciprocal
Oh.
functions.
Okay.
This is not reciprocal.
Negative square root of 3.
Well, pi over 6 is in this
You said that-
quadrant.
you said the inverse is negative.
No. Inverse is undoing. Inverse functions undo and go back to the original function. So the inverse of cosine is finding out what cosine gave us this number. So I know the inverse cosine is pi over 6. So taking the cosine on both sides, cosine of cosine inverse is just x in this case. And on the other side, you get the cosine of pi over 6. Dividing both sides by 6, we get cosine inverse of x equals pi over 6. And now if I take the cosine of both sides, because cosine of cosine inverse is just the argument of the cosine inverse. Just like if I had cosine inverse of the cosine of theta, that's just going to equal theta. Because cosine inverse gives me an angle, where cosine gives me a number. So x equals the cosine of pi over 6. Do that to my little cat at home. She just. And then I walk by her and she attacks my leg. Okay, question two. Is 5 through 6, right?
Yeah.
So work these problems, come to class on Tuesday with questions. On Tuesday, I will not work the review. I will answer questions about the review. So I expect you to do the review before class on Tuesday, because this is an excellent review for the final. Not the final, for exam 2.
Both pages? Or just this first?
It's just one page.
The both of them.
Oh, okay.
There are 2 columns. So it goes down to 24 problems. And the next page is the answer.
Oh, okay, I didn't, okay. Okay, yeah.
So unless you have specific questions for me today,
You're gonna include the
y'all
trig,
get to go 20 minutes early.
you're gonna include the trig functions. No, I mean, I'm sorry, the trig identities, the formulas, and this is gonna be in files? Those 3?
They're
PDFs?
there now.
They're there
I
now?
put them in there already.
Okay,
While I was talking about them, I put them all in.
Speaking of Tuesday, I have my driver's test for my license on Tuesday.
Well, if you work the homework, and you have questions, then there's always email. And we can set up a Zoom.
I have it early in the morning. The driver's test at like 9:30. Your class is at 2. I should probably inform my 9:30 class though.
yeah.
Okay.
All right, sir. Have a good what's today? Thursday. Have a good weekend.
You too, yeah. It starts as soon as I drive off campus, but I still have a bunch of work I have to get done, so. And I have office hours tomorrow. I'll be online starting around 10 o'clock. I already have somebody coming in. So.
A good weekend.
Y'all take care.